Cool. So, hey, this is Tasha. Today we're going to go over a presentation that is putting together a proposal for how we can all work together for the next couple months. It seeks to define some vocabulary that we found a lot of people coming into the working group are a little confused by. So, soft multi-tenancy, hard multi-tenancy, what are we looking at doing? And then we have some profiles that we're going over after we've defined those. There's a lot of content, and I want to make sure we get through it. It is all up for negotiation. This is a rough draft. It's not, this is in no way a final product. And there's some straw man architectures that are also very open for conversation. So what I'd like to propose we do is, stop definitely for comment, but try to get through the whole proposal in this hour. And then we're going to open up the presentation for everybody to make detailed comments on. And then I'll reach out to people who have, more detailed comments so we can make sure that we're kind of getting the whole feedback and kind of able to incorporate kind of more depth of feedback over time. And then we'll put together sort of the next draft of this and then share it with everybody. Are there any questions before we get started? Anything? Okay, great. So I'm going to hand it over to Sanjeev, who's done a ton of work on this, and he's going to take us through it.
Okay, thank you, Tasha. Can you all hear me? Okay.
Yes.
Yes.
Okay, I'm going to share some slides I put together, which has some of the content that Tasha was describing. Okay, so can you see the slides I'm sharing?
Yes.
Yes.
Okay, so a lot of this is content that many of us have discussed in various meetings and forums and prior threads. So we're just trying to consolidate and create a framework going forward. Okay. So what we're going to be covering is just to do a quick review of motivation of why we're doing this. Many people already know that, but since some of you may be coming from a slightly different background, we'll spend a few minutes on that. And then we'll talk about, some modes / profiles that we believe might make sense to pursue. And then we'll go into a little bit more detail on to what kind of work items would be needed to fully thrash out and define those modes. And then we'll cover some action items and next steps and timelines. Okay, so let me start. Very briefly, we will review why we are even doing any of this, right? And pardon me if some of you, this is redundant for some of you. So this will help us answer questions when we get it from outside of the working group, right? Why are we even doing multi-tenancy? So the motivation here is that clusters will need to be shared by multiple application teams. For example, it could be multiple development teams within an enterprise. And the benefits of shared clusters include reducing the number of clusters that are sprawled around in an enterprise, so reducing cluster sprawl, and improving the utilization of a smaller number of clusters, because you do not have to dedicate a cluster for every application team, and correspondingly not have to delegate nodes, servers, separate control stacks, separate monitoring stack, and so on. Reduce operations for the admin team because they do not have to maintain and lifecycle hundreds of stacks of Kubernetes plus Prometheus plus EFK plus Istio plus XYZ, everything that goes into building a production stack. So they'll have a fewer number of stacks to manage because each of those clusters will be supporting multiple teams. Again, what we're doing here is trying to formally define in upstream Kubernetes something that is actually already in common use. Projects like OpenShift and Rancher already have the concept of multiple projects, which are essentially like tenants within OpenShift and Rancher, or folks can do a kind of informal DIY namespace-based isolation. So the goal here is that since there are all these similar things going on, but not quite standardized, why don't we take some similar elements motivated by these similar work and formally define it in upstream Kubernetes, so that there is a essentially a standard way of doing multi-tenancy, which people are already doing through some proprietary types of or ad hoc kinds of solutions, such as OpenShift, Rancher, or DIY solutions. And we believe this is going to be more significant as the industry moves to containers running directly on bare metal, because there it'll be even less likely that you would want to give each app team their own dedicated bare metal cluster, right? I mean, think of a minimum of 3 all-in-one bare metal servers, or possibly 6 bare metal servers per Kubernetes cluster. Do you want to give 6 bare metal servers to every team? You probably don't. So as containers, as this technology is becoming more towards running containers on bare metal as opposed to running containers on a hypervisor, the need for multi-tenancy will be even greater, right? When you have VMs, the VMs provide a kind of a tenancy layer. So in some sense, that's why people are able to use Kubernetes today on top of a virtualization platform like VMware or OpenStack, because that provides the tenancy. But we need to design for a future where containers on bare metal play a big role. Okay, so we use the term multi-tenancy to refer to any kind of Kubernetes cluster sharing solution. And these solutions could have various levels of soft or hard boundaries between teams that we will call tenants. We can readjust the terminology later. Right now, we're using this terminology just for the purpose of our discussion. And in parallel, the current approach of using non-shared clusters will continue. So today, there are a lot of products which can create lots of Kubernetes clusters and give each team their own Kubernetes cluster, and that approach will continue. So we need to. So what we are saying here is that we are trying to do something similar to what OpenShift and Rancher does, but do it in a native upstream manner for the native upstream Kubernetes. So any questions on motivation, and are we all in agreement on the value of doing this? Okay, so hopefully we can answer these questions as folks from other working groups or ask us why we're doing this. So here's a potential reference model, right? And we have what I'm calling modes. You can think of it as profiles. Again, terminology we can adjust as we go. So a Kubernetes cluster will run in 1 out of n possible multi-tenancy modes. Okay. Whether for now these modes are for the purpose of documentation and testing, in future phases, these will be, the mode itself could be an explicitly configured attribute of the cluster, right? This cluster is running in mode 1 or mode 2. But we will do this gradually so that we want to get the sig-auth and other groups buy into our basic assumptions before we make too many assumptions about new Kubernetes objects, right? So we want to gradually get the buy-in from the community with simple solutions and then add new objects. If we straight away go and talk about new profiles, which are new CRDs, that tends to get resistance from the community, or at least from the different SIGs. So multi-tenancy mode 0 is effectively current Kubernetes, right? There is effectively no intra-cluster multi-tenancy. The entire cluster is used by a single team. But we may, as part of this work, add some security recommendations, such as a default security profile, even for this case, right? For the non-multi-tenant case. Okay, I know I've got a lot of text on these slides, so I'm not going to work through every sentence, but you can. We'll have the slides later. You'll be able to take a look later, or if you have questions on any particular point, feel free to ask. So mode 0 is that, right? Whatever we need to do to have baseline security without having actual multi-tenancy. But multi-tenancy starts with mode S1. And we're using it S1 to stand for what some people have called soft multi-tenancy, right? So in the past, there's always been these discussions about, well, are we doing soft multi-tenancy, hard multi-tenancy, and all. Let's put those down as effective, as precise modes, right? So mode S1 is enterprise soft multi-tenancy using current Kubernetes feature set, right? We are talking about what can we do today without creating any new CRDs, without creating any new controllers. We want to have a reference solution that will support n tenants per cluster, and it will rely on Kubernetes namespace, one namespace per tenant. Probably not define any new controllers. Again, if the team feels strongly, we could change that, but this is the current sort of draft thinking, and applies to both on-premise Kubernetes clusters as well as Kubernetes clusters hosted by public cloud or hosted Kubernetes, such as Elastic Kubernetes Service from Amazon and so on. But the primary reference model, which will be easier to think of, is an on-premises Kubernetes cluster, right? So we want to think of that case first, but eventually the solution needs to apply to hosted Kubernetes clusters as well. So that's mode S1. Mode S2 is soft. Yeah.
Sorry to interrupt.
Go ahead. Yeah, go ahead.
So for the mode 1 and the mode S1, is there any specific difference? Because if we don't run any additional controllers or we don't need any CRDs in the cluster, what's the difference between mode 1 and mode S1?
Yeah, mode 1 and mode S1 are the same thing, but really mode S1 has a curated reference configuration that this group will document and publish as a proof of concept for getting the sanction from the sig-auth for having the new controllers. So mode 0 is no multi-tenancy, okay? So the difference between mode 0 and mode S1 is a curated reference configuration that we will curate and document as part of this team's output. Okay, and that might include some sample automated tests. Now, let me explain the point here. We want to, what we've heard from a few different people is that if we directly go to, let's say, sig-auth and say, you know, we want to define new controllers, then, and I think you've seen this in response to the keps that you had introduced, right? It tends to take a long time to get approved, and there's some amount of resistance to it. So what we are proposing here, and this is up for debate, of course, right? So feel free to agree and disagree. So what we are proposing here is that to make things easier to start with, we simply have a documented reference model without new controllers, but we clearly document and provide reference configuration for everything from pod security policies, network security policies, RBAC, and so on, for somebody to develop, to add this to their existing cluster. Using that, we give a demo to the sig-auth team, and that then hopefully will give us a better blessing from them that, okay, this makes sense. Now put a controller on top of this, right? But that work can continue in parallel to the work for S2, right? We can continue we can start off doing the controller work in parallel if we feel that is appropriate. But we don't have to necessarily couple it, because functionally these are two different pieces of work. Agreeing on the right curation model is a different task than implementing the controller for that curation model.
Is it a requirement, in your opinion, for the controller and the custom resource to exist in the upstream Kubernetes project, or would you see this being more of a community effort?
So that we'll have to, all these are great questions. So we'll have to play it by ear based on the response we get from folks like sig-auth. Eventually, we may want, it would be great if we can actually put the controller in upstream trunk and make it an official trunk feature. But what we have heard from different folks is that when you try to do that, the various SIGs tend to be very, very circumspect because they really need a lot of justification. So what I'm saying here is that let's use mode S1 to build confidence, essentially a proof of concept, to agree on the parameters by which multi-tenancy is defined. Somebody can use it today and build their own DIY, but they can refer to our standard recommendation. So you can think of mode S1 more like a best practices document. Whereas mode S2, we develop the controller, but we feel that the controller has more chance of getting into upstream trunk if we have already got buy-in with our work around S1. Now that's the thinking so far. Feel free to, agree or disagree.
I think I agree that mode 0 and mode S1 don't seem to have like enough significant differences that I can understand for them to be discrete. But I think having S1, S2, and H1 makes sense insofar as H1 has a lot of features that are like hitherto unknown. We don't have the features required to build H1, so that like part of digging into that will have to be discovering and digging into the deficiencies there. But for S2, if you did want to build a custom resource definition and a controller, I think one of the best things about the CRD APIs is that it's really easy to build them as external projects, and then if and when it makes sense, integrate them or leave them as additional add-ons, depending on what makes sense once they're like complete and being used.
Exactly. That's the thinking. And if for any reason the SIG, let's say sig-auth says this work we don't think should have its own controllers, then S1 is still useful by itself, right? We are not gating the two. S2 is not just new controllers, but S2 is also some new, we expect that, there's new work happening with Kubernetes runtimes, with things like kata containers and so on. With S2, we would potentially have explicit CRDs for the concept of a tenant itself, right? So there would be concept of tenant as a new object, as well as tenancy profile as a new object. So there would be two categories of new objects. One is the tenants themselves, and secondly is the tenancy profile, right? To get buy-in from sig-auth for all of that might take time. So we develop it for, yeah.
So I just want to jump in. Tim Hocken did a lightning talk at Kubecon about how they actually want to turn all of the upstream, all of the current trunk stuff eventually into CRDs, and so they're actually wanting to get less controllers in the trunk rather than add more. I think is their strategic goal. He didn't really say what timeframes, but does anybody else see that one?
Yeah, I was there. It seems clear that they wanted everything to be in that time frame, even core pieces.
Right.
Yeah. Hi. Another example is the dynamic volume resizing stuff. There was a lot of discussion in the sig-auth where it was initially proposed as something that is built in, and then it moved into a separate controller and CRDs. So the pattern is already set, which is basically do your CRDs, do your operators, and whatever else you need, and then make sure that things work, and then it'll be easier to get things into the main trunk. But the idea here, I guess, is that we should make sure that we can work on this on our own quickly, and only if we need some basic primitives that we need in S2, then we can have a smaller kep, which might have a easier time to land, say in sig node or something like that. Does that make sense?
Yeah, the way I was looking at it is that we would work on both S1 and S2. As we go along, we might move things. We might actually merge S1 and S2 because this is really the same thing, or we might add the ability of controllers into S1, but still keep S2 for, let's say, future Kubernetes capability, which still needs soft multi-tenancy, right? So there is still more. Let's say that Yisui's KP on namespace population, that's an example of self-service. These are logically separate things, so they could come in later. So at the moment, I'm not assuming a specific boundary between what falls into S1 and S2. This is an initial thought, but we can move things around between an S1 and S2 as we see fit. And that may include, okay, we do need a controller for node S1 as well. Or we may say these are really the same thing, and we just, the way I've split this is simply to get some working POC first using S1. So the boundary between S1 and S2 is kind of fluid at this time.
Right.
So,
Sanjeev, question regarding 0, S1 and S2. Like today, without implementing any of that, can we assume that like S2 is the superset of S1 and S1 is a superset of 0? Will we be building upon things, or do you think they would be entirely disjoint set of features?
Yeah, no, you can think of it that way. You can think of S2 as a superset of S1. So really,
Okay.
there are fundamentally, it does come down to two categories: soft multi-tenancy and hard multi-tenancy. And
Right.
only the reason I split up soft into S1 and S2 is S1 is soft multi-tenancy using mostly today's constructs, and S2 is soft multi-tenancy using future constructs. But the broad categories are still soft and hard. That's really it. We don't want to create 5 different categories.
Sure. And the work in making all the tests work, when these configurations are placed, where do you bucket them? In S1, I guess, but just want to know what your thoughts are.
So S1 is more towards the profile definition of Kubernetes objects like hot security policies and so on.
Sure.
S2 has more of that, right? Plus it has the controller mechanics of enforcing those policies. So, but like I said, the control mechanics could end up in S1 as well. So really the baseline way to look at it is S1 is soft multi-tenancy using currently available functionality. Maybe we stop at Kubernetes 113, right? Basically using functionality up to and inclusive of 113 Kubernetes. That's what S1 is. And S2 is all additional capabilities / new controllers, possibly, using all upcoming capabilities in Kubernetes 114 and beyond. So this basically puts a timeline on S1 as essentially really the next 3 months worth of functional content.
But I think my question is, while we deliver S1, would we also make sure that tests that need to be passing are passing with all that in place if those changes are applied as PSP or any of that? Or do you think that will be more an S2 thing?
Yeah, so, okay. So is that Tim's? Tim, was that you?
No, that was not me.
Okay, so I had
that was John.
chat with Jim. Yeah, John. So Jim and I had a chat today. Jim is very much involved in the conformance testing and so on. So his suggestion was that for something like mode S1, we can create a third-party test suite. It doesn't have to be part of the official Kubernetes conformance tests initially. We use that third-party test suite as an additional, optionally available test suite. It's available as a best practices document, as well as we use that to demo this when we demo this to S1, to sig-auth to get their blessing. Okay, and then when we do S2 is we do a formal test suite. So we will have test automation both in S1 and S2, but in S1 it'll be more like a third-party test suite, just as a
validator,
proof of concept that we've got some tenancy separation. And then S2 is where we have a formal test suite.
Right. I can add a little bit more color. So in S1, the idea is that it is targeted towards existing users. They can just pick up what we publish, and without adding more binaries, more operators, so CRDs, they should be able to apply it to their existing environment. And then the conformance tests should work, as well as these additional tests that we write should also work. And the idea is to have a test suite which will publish to the test grid, runs against master, and make sure that all the things that we say in our document is not broken, essentially.
Got it. Okay, thanks.
Yeah, and again, as Sasha said, this is just a draft set of thinking, right? This is a straw man to help us all think about these things, and we can adjust it as we go. Okay, and then finally, mode H1 is where many of the folks have said we need to be thinking of sort of the ultimate multi-tenancy solution that could include things like totally independent control planes per tenant, true isolation across all dimensions, whether it's control plane management, monitoring, logging, all of that, and truly supporting untrusted current tenants within the same cluster, essentially like an IaaS level multi-tenancy. That will require quite a bit more work and potentially new machinery and core Kubernetes constructs like the API server. So yes, that also we can start in parallel, but we don't need to gate the other one. So allowing this kind of categorization essentially allows us to work on S1, S2, and H1 in parallel. Their closing dates would be different. S1 is something, we're thinking about next few months, right? S2 is still, within the year, within 2019. S1 could be 3 to 6 months. S2 could be, 6 to 12 months. And then H1 could be potentially post 12 months. Okay.
So,
but we could start on all of these in parallel. Yeah, go ahead. Any questions?
Yeah, so I guess with H1, I guess one of my questions was, I've been looking a lot into like the federation kind of capabilities being added. Does H1 make sense to maybe more so kind of go down that route of almost like a federation type feature where there's a master Kubernetes cluster that, the admins are using, and they're basically giving sub clusters for others to use? Or I guess, have you thought of that, or how does that fit?
Yeah, so, I had not. So federation and multi-cloud is an interesting point here. Yes, obviously, a full, comprehensive solution would need to be part of H1. But because even for S1 and S2, we are saying it applies to not just on-premises Kubernetes clusters, but also the Kubernetes clusters hosted by public cloud providers like EKS and JKE and all that. So there is some amount of multi-cloud in S1, S2 as well, because we are not saying that in the long term, if somebody has H1, they will not need a soft multi-tenancy at all. There could be intra-enterprise use cases where they never need the complexity of hard multi-tenancy, right? Because this is all within an enterprise. So
right.
There is yeah, go ahead.
So I guess my question is, I guess, would H1 be almost more, I guess, better suited towards like a federation type scenario, and then if you need soft multi-tenancy within those federations, you could do that. But I guess Or I guess I'm wondering, like H1, if we really have to basically isolate the entire control plane and data planes, does it not make sense just to do basically hierarchical Kubernetes clusters with different masters that are controlled by others? I mean, I don't know if that I guess is way out of bounds.
Yeah. So we are very early in H1 thinking. I personally have been thinking mostly about S1 and S2. So yes, what you say could be valid, but we really need to think it through. This is a straw man. Let's all think about it and contribute our thoughts. So yes, you could be right, but I have.
Yeah. I'm just, I guess,
Yeah.
wondering if that's been brought up or if we've kind of discussed that at all.
Yeah. So let's keep moving. All valid thoughts and all good thoughts. I just want to give an aside just to illustrate a side example from OpenStack. Not that I want to model this on OpenStack or anything like that, but just to give you an example of another platform that has multi-tenancy, right? In OpenStack, as some of you probably know, there is a single API server. So API server is not per tenant, even in OpenStack, but it has strong internal data plane and management plane isolation across tenants. So there's a, for example, this is showing OpenStack Lance, which is one of the OpenStack services. It's a single API server for multiple users of multiple tenants coming in through that API. But then internally, there's isolation, but the API server is not partitioned. So just something to keep in mind, that you can build a pretty strong, hard multi-tenancy boundary even without splitting up the API server. But in that case, they typically put things like rate limits per tenant. So there is all of the separation between all these categories is not black and white. It's slightly gray, and we'll have to take a stab at it and iterate it as we go. Okay, so that's just a side example of OpenStack, but we don't need to spend time. Sometimes there's a question, does soft multi-tenancy need to be standardized at all? And the working assumption is yes, because, you know, people are doing this already today. People are doing this with OpenShift projects and Rancher projects. So if we do not standardize this in native Kubernetes upstream, we don't have the analog. There's always loose discussion. Well, you can do namespace-based isolation, but what exactly does that mean? That's what we are trying to standardize. Okay, and same thing, we will validate that using CI testing and conformance testing eventually. Okay, and then how do we work with overlapping work in other working groups? Well, we have a well-defined reference architecture which we collectively build, and then we create dependencies on other working groups and we track those dependencies, and we expect to be needing to deal with lots of other groups like the ones listed here. Okay, so we create our own reference architecture, we do proof of concepts with it, we develop controllers as we see appropriate, but in many cases we'll have to just track dependencies on other teams. It could be, for example, defining new features in the way network policies are done, or in the policy working group, okay, or in the API machinery. So that's how we're going to do this. So in order for us to do that, we need to have a well-defined reference architecture, which is what we are trying to lay the foundation for here. Okay, so that we can then point to that. Here's our reference architecture when we go talk to sig-auth or sig-auth and so on. Okay, so now a little bit specifics on what the cluster, multi-tenant cluster will look like. So again, I'm going to focus mostly on S1 because just to keep things simple, but S1/S2, right? So in this model, it's one namespace per tenant. So here we have 3 namespaces, tenant A. We're using existing RBAC, like admin, edit in view. And we have created a role for tenancy admin, okay? So because this is S1, we don't have the controller. Once we have a controller, the controller can do the job of the tenancy admin, but right now it's a manual process. This tenancy admin is responsible for creating and deleting tenants, okay? So, and this tenancy admin has the privileges to create the isolation boundaries between tenants. the tenants themselves do not have that privilege because they can step on each other if they've had that privilege. So there is, the separation is via, again, because right now we are talking about S1 here, existing constructs of RBAC roles, and I have some samples in the upcoming slides, and opinionated pod security policies and network policies, example. So the initial model could very well be that we do not allow any privileged containers in the tenant space. Well, we'll come back to that, but that's an example of a opinionated policy, which the tenancy admin would provision. So bottom line is that there is a separate out-of-band process for creating projects, right? And only this role can create, delete namespaces and label namespaces. And very likely this would also be the only role that can create network policies. So a Kubernetes cluster would look something like this. You would have system namespaces like kubesystem and kubepublic, and we would need to support the notion of shared services, which we would, in our reference architecture, would say that those shared services need to run in the default namespace. And each tenant gets their own namespace. The tenants are isolated from each other, but services in the default namespace can access one or more tenants because they're providing shared services to one or more of these tenants. These shared services are things like a monitoring service, a registry service, an ingress controller service, and so on. So, and there could be multiple instances of these. So for example, there are two instances of ingress controller. Ingress controller 1 needs to be able to provide service to tenants A and B, and ingress controller 2 may be providing service to tenants C and D. So in the curated reference model that we would publish, we would need to define the reference security policies to support this sort of a model. Yeah, and then the default namespace also has things like monitoring services, and which we would model as Prometheus-based monitoring. This is very much modeled after OpenShift. OpenShift kind of does something like this. There are shared services running in the default namespace, and individual projects run in their own namespaces. They also have the concept of joint tenants. A joint tenant is where tenant A and B can actually talk to each other. They are not isolated. Initially, we would go with the model that all tenants are isolated from each other, but we may want to support an additional capability of joint tenants. And then the other thing is having multiple. Do we want to have all services running in the same default namespace? Is that, as part of our security analysis, we would need to, convince ourselves that, okay, running ingress controller for tenants A and B, and another ingress controller for C and D, but running them both in the same default namespace, is it fine, or do we need multiple services namespaces? So the point here is that having a reference model for how we're going to lay out the namespaces. Was there a question?
May I ask a question? Who's the owns these shared service?
Who owns what?
Who's the owner of these shared service? Because it seems like to me, tenants don't own the shared service.
No. So in this model, the shared services are owned either by the tenant admin or the cluster admin. These are centralized shared services. If the tenant owns his own service, then it runs inside his own tenant anyway, in which case we don't care about it. It just looks like an app. The reason we have brought this out here is because the model needs to cover the concept of shared services which are not owned by the tenants, just consumed by the tenants, but provided by the cluster admin or the tenancy admin.
So today, if service provided by the cluster admin, most of them will sit in the Kubernetes system.
Well, that's debatable. I mean, there are cases where people feel that kube system should only have the actual Kubernetes control plane, but things like Ingress and Prometheus should actually run in the default namespace, which again, by the way, is what OpenShift does. So a lot of this, what I'm showing here, is essentially modeled by, doing what OpenShift does. So a lot of these soft multi-tenancy models is to make it very OpenShift-like. But again, this is a straw man. We are up for debate.
I have another question. If a tenant wants to provide a service for all other tenants, for example, if I want to provide a Postgres database for all other tenants, so the tenant is responsible for setting up all these configurations inside the tenant's namespace, right?
Yeah, that's the tenant's own private services that he wishes to expose to other tenants. So we wouldn't, at least initially, need to accommodate that. A tenant can expose through his normal north-south endpoints any service to other tenants. Like I said, we could have the concept of joint tenants. It's up to this team when we want to support that, at what point. But again, OpenShift supports that, and that tells me that there are customers that occasionally need that. But for now, to keep things simple initially, we would first create a reference model where if tenant wants to give a service to other tenant, fine, that's private to them and we don't need to take care. But we need to have a reference model for these kind of shared services. Remember that when we're talking about multi-tenancy here, these are essentially multi-tenant services because single instance of these services is consumed by multiple tenants. So that's why it's part of the multi-tenancy architecture. Now, I agree that we may be boiling the ocean here, so we may decide to defer this point until later. In this comment, we are just laying out the things that we may need to discuss, may need to define. Whether we define it in the first phase or in the second phase, that's a separate discussion.
So I really like what you've done here, Sanjeev. I pretty well agree with most of it. I just want to chuck in one other thing though, because not to dive into it now, but just to put onto the list of things to think about is because you've got the ingress controllers there. How then does DNS integration work in this model? So if people...
That's a great point. I haven't thought fully about DNS, but because DNS has, I'm hoping that we will find that using RBAC, we are able to maybe cover all the DNS aspects, or just the fact that tenants have network separation. So that may be adequate for DNS, but yes, we need to think a little bit more about DNS. So it's one of the work items that we need to think through. I have some notes on the CNI in a couple of slides, but DNS is something that probably needs more thought. So, for example, if tenant A introduces a service which has a DNS name, you do not want tenant B to be able to snoop on or to be able to retrieve DNS binding which is meant for tenant A. Right. So what needs to happen is the current DNS infrastructure adequate? We have to investigate, and if there's any gap, then we'll have to address it.
Yeah,
Well,
so I don't think we don't need to solve it now, but that's one of the. So if we said in S1 we're not having CRDs and things, you can still kind of do stuff like that with admission controllers and just labels and things. But I think we should.
Right. So we'll see what can be done with existing objects, and that will tell us, what new objects we then need to add in future models. So here's a sample config of model S1. This is not complete, but this will give you a feel of what we need to define. So there would be cluster install requirements, right? So curated config for the API server, we disable ABAC, disable static auth, enable RBAC, enable audit logging, have a curated set of admission controllers. For example, we need pod security policy, always pull images, etc. These are all very relevant for multi-tenancy. And we need to make sure that this is set according to our recommended design in both our manual solution as well as the automatic solution, right, with the controllers. But with the manual solution, we get to verify it. So we get to verify that this is exactly the right combination of install requirements to support the multi-tenancy model. And then the baseline, we would align with CIS requirements. So CIS publishes requirements on everything from what the correct API server setting should be to what's the file permissions and so on. So we would define that as part of the model definition. We would start initially only with the Docker runtime, but at some point we will need to also allow for the possibility of other runtimes like CRIO, Kata, and Firecracker. Okay, but we'll start with just Docker. And we would start Model S1 with some common plugins, but it should be minimally dependent on the type of plugin. So for example, we could say the network plugin is Calico, the cloud provider is vSphere, right, to model a common on-premises cluster running on vSphere initially. But the devil is in the details of how precisely we define the model. These are all the parameters that we need to have a next level of deep dive on. So there's the cluster level parameters, and then there is the tenant or namespace level. So here we will define the curated RBAC, like for example, the new tenant admin role, and set it up to be the namespace manager. And also be the only role, we need to be able to not allow other roles have the ability to create namespaces. We don't want developers creating namespaces because namespaces equals projects in this model, right? So setting up that curated RBAC model for various Kubernetes resources. Within the namespace, it looks like we should be able to retain the current Kubernetes default roles, RBAC roles. So admin, edit, and view seem to be fine. We would have a small number of curated pod security policies, which we meaning this group, would believe is the right pod security model to support multi-tenancy. And I have one other slide on that as well. And similarly for the other things. So basically, as we define Model S1, we'll be defining these precise parameters, and then subsequently adding the controller to enforce this. But even if you don't have the controller, this would be the reference model. Okay, so just to get you a feel of the parameters. Here is the same checklist, but a little bit bigger checklist. There's actually more. That was sort of high-level points. We would also need to cover things like secret separation, right? Secrets per namespace. Storage separation, right? What would be our curation model for setting up, using existing constructs, persistent volumes, and storage class quotas per tenant. And then to what extent we want this to apply both to the on-prem as well as to the public hosted model. We'll have to see as how much of that we can put into Model S1. So we haven't fully defined model S1. We're just looking at the kinds of things that we need to cover. Right? We talked about services tenants, meaning that putting that default tenant for having the services. Another thing is for application automation, right? So in this multi-tenant model, very often people will want to have Helm and pillar-based architecture for deploying applications to the tenants. But pillar has some known security issues. So what would be a reference model for allowing Helm and pillar to work in this model? So that's what we would need to capture as well. This is the bigger checklist. We can decide how much of it we actually do, but this is just to give a feeling of the scope of things. Audit logs per tenant, right? Audit logging, maybe this is all covered by just having the right RBAC, but we would need to test it out to make sure that there are no gaps. And if there are gaps, then that will uncover new work items. And then we talked about things like joint tenants and multi-tenant sprint tenants. Other things which for now I said were not in model S1, but the boundary is fluid, so we could add it. They're on the radar. Multiple runtimes like Docker, Sierra, and Kata. Self-service tenant automation, similar to UC's proposal for namespace templating. Explicit new CRD, right? We said it's not in S1, but again, S1, but it could be part of S2, or we could merge it into S1. And then tenancy-aware monitoring and logging. So we haven't talked yet about monitoring and logging. If the goal of this working group is look at all aspects of multi-tenancy, that includes monitoring and logging. So Prometheus is now supporting multi-tenancy to some extent. So we would need to investigate that and say, okay, how can we integrate multi-tenant Prometheus into this namespace-based Kubernetes multi-tenancy and have a reference model for that. Same thing for the EFK. Tenancy-aware container registry integration. So assuming that Harbor is the registry service for such a cluster, Harbor has the concept, Harbor is the multi-tenant capable Docker registry. But that multi-tenancy would need to be integrated with the Kubernetes multi-tenancy through common, and maybe that is largely common identity and RBAC. But whatever that work is, we need to define how much of that we are going to provide an opinion on in S1, or how much of that we leave it open for people to do what they want. But it's going to be a balancing act between how much we have an opinion on versus how much we won't define and let people do whatever they want. And we'll have to learn the right boundaries over time. Okay. So that's a bunch of things on. So let me see how much time I have here. Okay. So we are actually close to the end of the time here. So I'll just run through the rest of it, and you can look at it later. So again, on mods, we talked earlier about pod security policies. I looked at a couple of options. Rancher has like 2 standardized pod security policies, whereas OpenShift has 7 standardized pod security policies. So what should we do? So maybe the proposal for now is maybe we start only with 2 curated pod security policies, similar to the Rancher model, and we don't support all this flexibility like OpenShift. Maybe over some time we do it, but maybe not initially. And here's the example of the pod security policy. So I'm going to skip past this. I'm going to skip past this as well. I haven't added details on how much opinionated we want to be in terms of whether the currently recommended default SC Linux AppArmor policies are adequate, or whether we find some gaps there. Okay, but we'll start with whatever is there and see whether it's adequate, and if not, at a minimum, we need to understand it so that we can able to know what is the level of support we have in the current model, in the model S1 and S2, and that might uncover us new gaps which we do in future phases. Network, having a reference architecture for the CNI and the network policy. So similar model as we said before, but one issue is that we cannot use network policies to do both tenant isolation as well as intra namespace isolation, right? Because if we want to do intra namespace isolation, then the tenant user would need to have right privileges on the network policy. But if they have right privileges on the network policy, they can end up covering the isolation boundaries. So initially, what we would have, the assumption of this model would be that tenants do not get the ability to do intra-tenant microsegmentation. Network policies are only used for tenant isolation. There are advanced CNIs which can do both, meaning they can do both tenant isolation and still give the flexibility to the tenant to do intra-tenant network policies. Maybe we don't include that model initially, but some implementations might choose to do that to give more flexibility. We have to define a, if you will, a least common denominator solution that works with all CNIs, but some CNIs are actually already namespace aware, so they can do more. But we go with the baseline CNI, which is not namespace aware. Okay, so there's some detail here, which I won't talk through this, but, and there was a question earlier about DNS records. So again, we need to scrutinize that to see whether the current capabilities are adequate for namespace-based tenancy. So here's an example of a network policy. If you take the least common denominator approach, you can use a simple policy like this to do namespace isolation, but you don't have any egress controls here, and you also cannot use it for intra-namespace isolation, but maybe that's fine for the initial model. There's a bunch of text here which is very wordy, so I'm going to just point to what it is, and you can look at it later. So it depends on how deep you want to go into monitoring, the multi-tenant container registry service, the Kubernetes ingress, and multi-tenant logging. Maybe we defer this to a future model, but it's something that we need to start thinking about if we want to have a complete solution. So action items and next steps, right? Of course, we'll discuss this offline with Sasha and David and others, but some thoughts are that we would move this information formally into a working group architecture or a framework document that we could all edit or comment on and have that in the wiki page. We would kick off threads potentially for all the models like S1, S2, and H1, but in particular for S1, we want to make earlier progress because that's mostly using current capabilities. So we should be able to target that for the next 2 and maximum 3 months, really. I'm talking about 1 to 3 months maximum for fully documenting that. And to limit that scope further, we only focus for on-premise cluster. We don't focus on cloud clusters. We don't focus on things like service namespace maybe initially, right? So we reduce the scope to keep it manageable for the short term. And once we have some wins, we can expand the scope. And then we start working on a third-party test suite repo and add some initial tests for mode S1. And we use that to give a demo or a readout to SIG architecture. And SIG architecture hopefully will then come back and say, yes, we agree. And, you know, you've got a reference model and, you know, you've given a demo using, so they can bless it for the full controller-based solution, including soft and hard versions, right? So that's how we try to phase it. And then in parallel, we work on the PRs for model S2 and H1 and get those into the conformance. So I know this is all kind of just speculative, but we're really talking about, you know, the next essentially through end of March to kind of have a reasonable S1 model, have a demo with it, review it with sig-auth. In parallel, we work on the other models as well as the conformance tests, and that we'll have to wait and see how those plays out. And hopefully we can do a demo at Kubecon Europe, in which we demo at a minimum mode S1, and hopefully parts of mode S2 and H1 also, which is in the end of May timeframe. So that's about it. Sorry, I may have rushed through some parts quickly. Hopefully you got a feel for it. Still very strawman, so please think about it, provide your comments, and we'll see how to take it forward.
Thanks, Sanjeev, for going over that. We will share this over the a link to this document over the mailing list and in the agenda, as well as a video of this conversation. And so if everyone can just go through it, add your comments wherever appropriate, and then we'll start kind of pulling those in and then try to put together a second draft and share that with everybody as well. And if, yeah, so be as detailed as you can, and we'll take it from there. Thank you, and thanks everyone for joining today.
Thank you.